We're now going to have a look at what it looks like to build our first rig in Aniseed. So, providing you're on the rigging workspace, Aniseed will appear in the top menu here. If you expand that menu and choose Aniseed Builder, it will load Aniseed and embed it on the right hand side of Maya's window. I'm in a blank scene, there's no rigs in the scene, and so this is currently empty. I'm going to go to File and choose New Rig. I'm going to give a name for my rig, in this case Demonstration, and that will create a rig in the scene which is starting as just a group node. And it's then generated a stack for us. And there's one component added to the stack by default, which is our rig configuration component. This is the only component that's absolutely mandatory for any given Aniseed rig. The rig configuration component allows all of the components to inspect and generate names that adhere to the naming convention that the rigger decides upon. But a rig configuration can also add additional functionality. For instance, if I right click this and go to Actions, you can see that we can enable and disable a component. We can also force a component's version, and we can export and import the settings of that component. These are common to all components, and then various components can add additional component-specific functionality, and the rig configuration component in this case gives us the functionality to create an initial component structure. I'm going to go ahead and click that. That gives us a whole series of components in our stack by default, and that's because quite often the first few steps of building any rig are typically the same. In this case, it's added a substructure component, so it's going to create a group node for our skeletal hierarchy, our control hierarchy, and our geometry. It's then created these two organizers. Now, organizers don't do anything in and of themselves, there's no code executing, but they're a great way of grouping bits of functionality together. And in this case, it's added one to define the concept of making a rig editable, and within here we're storing control shape data, and then we're deleting a control rig. Under the build control rig organizer, it's added a global control rig component, an apply shapes component, and a color controls component. So let's go ahead and build this rig. Each one has gone green to say that it built successfully, and if we expand our outliner, you can see that we've got our skeleton group node, controls group node, and geometry group node, all of which adhere to the naming convention defined by the rig configuration. We've then executed the build control rig, which has given us the control shapes and constrained the joint to the control. Now, one thing I'm going to do is I'm just going to parent our root joint under the skeleton group. That way we're always guaranteed to ensure that we've got an exportable hierarchy that's completely separate from our control hierarchy. And that's an important concept if you plan to put your rig into a game engine. Okay, so we've got a basis, a starting point if you like, for our rig. I'm going to go ahead and make our rig editable again, and I'm going to add a spine component into our rig. So I want the spine component to build after the global SRT, so I'm going to right click the global SRT and choose Add Component. This will list all the components available to us. I can also start a filter, so for instance you can see here we've got two types of spine that I can apply. There's an FK spine and a spline spine. I'm going to choose the spline spine for this example and click Add. It's going to ask for a label, I'm going to leave that as default. The label is just the name it appears as in this component list. So we've now added our component, but it hasn't fundamentally changed the scene in any way. So I'm going to go ahead and select our global joint. Now I could manually draw the joint chain, and as you can see with the spline spine, we could then fill in these fields with the manually drawn joint chain. Alternatively, I can right click the component, go to Actions, and you can see this particular component gives me the ability to create joints and a guide. So I'm going to go ahead and choose Create Joints. It's asking me how many joints I want, and I'm going to choose 6. And if I reselect this, you can see it's automatically filled in the root joint and tip joint with the joints that it's created, and it's also created this guide hierarchy. So I can go and grab our guide and start to manipulate it into the position that I want. So now I've got a nice S to my spine, but crucially by using the guide I know that my transforms will always reach when a spline rig is generated. So with this done, I've added my component, I've got my joints made, I'm going to go ahead and attempt to build our control rig. And immediately nothing goes green, none of the components were executed, but our spline spine has gone yellow. And it's gone yellow to say that it's failed its validation. So every component has a validation test performed over it before the stack is executed. If you hop over to the script editor, you'll be told which component failed validation and why. So in this case, it's telling us we must remove the guide before building. So I'm going to right click our spline spine component, go to actions and remove manipulation guide. And let's try building again. And again, we're still yellow. Therefore, our rig is refusing to build because we've failed validation. Now this time, it's telling us the parent for the spline spine has not been set. So when we built our joints, it's filled in the root joint and the tip joint, but we haven't told it what the control parent should be. And in this case, we want the control parent to be a control that our global SRT builds, but it doesn't exist yet in the scene. So with any field like this, we can type the name of an object. Equally, if an object exists in the scene, we can click this button to autofill it. But if we know that the object that we want to fill this with is an output of a component that comes before it, we can simply right click that field and we can see any parent object, or sorry, any parent component in this list here and the outputs of that component. So in this case, the global SRT component promises to fulfill a main control and a location control. And so I'm going to choose the main control to be the parent. By doing this, I'm not hard coding the name of that control in this field, I'm simply telling it the address of an attribute on this component. That way we can change the naming conventions and this will all still continue to work. So once again, let's go ahead and build our control rig. This now all goes green, we have no validation warnings and we've got a rig in our scene. One thing you will notice is our controls are aligned to our root joint, which in this case is not exactly what we want. So I'm going to go ahead and select our spline spine component and go to the options tab. This is where we'll see any options for the selected component and allow us to tailor the build. So for the spine in this case we can change the name, but we can also change some of the behavior. So in this case I'm going to turn on the orient controls to world and lock the end orientations of the controls as well. I'm then going to right click our rig and choose to rebuild our rig. And you'll immediately notice that all of our controls are now aligned to the world and should work as expected. Now at any point obviously I can go back and make our rig editable, and any component that offers a guide I can simply right click and choose to recreate the manipulation guide and remanipulate our guide and reposition our joints and continually rebuild our rig. And that's the fundamental principle of Aniseed, where each component is just an item in a stack that gets executed. You can create any amount of organizers to create different sections and execute different sections of the stack independently or as a whole rig.